Hello everyone, welcome back to my YouTube channel Factory Discovery. How an iPhone is made. From raw materials to the device in your hand introduction. The device billions of people carry every day. Take a moment and look at your smartphone. It probably feels ordinary because you use it every day. You wake up with it beside your bed. You check messages, watch videos, take photos, navigate unfamiliar places, and stay connected to people across the world. For billions of people, a smartphone has become one of the most important objects in modern life. Yet very few people ever stop and ask a fascinating question. Where did this device actually come from? Not where it was assembled, not where it was sold, but where it truly began. Because the story of an iPhone starts long before it reaches a store shelf. Long before the screen lights up for the first time. Long before a customer removes the protective film and powers it on. Its story begins deep underground, hidden inside mountains, deserts, and mines spread across multiple continents. It passes through some of the most advanced factories ever built. It travels through laboratories cleaner than operating rooms. It requires the work of engineers, scientists, technicians, designers, programmers, logistics specialists, and manufacturing experts. Millions of individual components must work together flawlessly inside a device small enough to fit in a pocket. What makes this even more remarkable is that the entire journey repeats itself hundreds of millions of times every year. Today, we're going to follow that journey from the very beginning. We'll discover how ordinary raw materials become one of the most sophisticated products ever created by humanity. And the first chapter begins in a place most people would never expect. Underground. Part 1. The hidden materials inside every iPhone. Every iPhone begins as a collection of raw materials extracted from the earth. Although the finished device appears simple on the outside, it contains dozens of different elements working together. Aluminum forms parts of the frame. Copper carries electrical signals. Gold helps create reliable electronic connections. Lithium stores energy inside the battery. Rare earth elements support speakers, vibration systems, and advanced components. Silicon powers the processors that make everything possible. To obtain these materials, massive mining operations operate around the world. Some are located in remote deserts. Others are hidden deep within mountains. Gigantic excavators remove enormous quantities of rock, while haul trucks carrying hundreds of tons travel continuously between extraction sites and processing facilities. The scale is difficult to imagine. A single smartphone contains only small amounts of these materials. Yet when hundreds of millions of devices are produced every year, the demand becomes enormous. After extraction, the raw materials enter a long chain of refining facilities. Here, engineers separate valuable elements from unwanted material. Through heating, chemical processing, filtration, and purification, the materials gradually become suitable for advanced manufacturing. Among all these materials, one stands above the rest: silicon, because silicon will eventually become the brain of the iPhone. And its journey is one of the most extraordinary manufacturing stories on Earth. Part 2. Turning sand into microchips. At first glance, sand appears completely ordinary. You find it on beaches, in deserts, and along riverbanks. Yet hidden within sand is silicon, the foundation of modern computing. Inside highly specialized facilities, silicon undergoes a transformation unlike anything else in manufacturing. Engineers begin by purifying it to extraordinary levels. The final material becomes so pure that even microscopic contamination can affect performance. The purified silicon is melted at extremely high temperatures and slowly formed into giant crystal cylinders known as ingots. Creating these crystals requires incredible patience and precision. The process can take days, and even the smallest imperfections can result in failure. Once complete, the ingots are sliced into thin circular wafers. These wafers may appear simple, but they are about to become some of the most advanced pieces of technology ever manufactured. The wafers enter semiconductor fabrication plants, often called fabs. These facilities are among the most advanced factories on Earth. Air is filtered continuously. Temperature and humidity remain tightly controlled. Workers wear specialized suits designed to prevent contamination. Inside these facilities, machines use light, chemistry, and advanced engineering to create billions of microscopic transistors on each chip. Layer after layer is added. Patterns smaller than human hair are created with astonishing precision. Months of work may be required before a single processor is complete. Yet the result is extraordinary. A tiny chip capable of performing billions of calculations every second. What started as ordinary sand is now becoming the intelligence inside an iPhone. But intelligence alone is not enough. A smartphone also needs a way to communicate with its user. And that brings us to the display. Part 3. Creating the screen that defines the experience for most users. The display is the smartphone. Every message, photograph, video, application, and interaction appears through this thin layer of glass and electronics. Creating it is far more difficult than most people realize. The process begins with specially engineered glass produced under highly controlled conditions. The glass must be exceptionally smooth, incredibly strong, and optically perfect. Even tiny imperfections can affect performance. After manufacturing, the glass undergoes strengthening treatments designed to improve durability. Engineers carefully control every stage to ensure the material can withstand daily use while remaining thin and lightweight. At the same time, separate facilities manufacture the display panels themselves. Millions of tiny pixels are arranged in precise patterns. Advanced production equipment deposits microscopic layers of materials onto the panel. Electrical circuits are integrated throughout the structure. Every display is tested repeatedly. Brightness is measured. Color accuracy is verified. Uniformity is checked. Touch sensors are added so the screen can detect every tap, swipe, and gesture. The complexity is astonishing. Millions of components must work together perfectly to create a smooth and responsive experience. When the final layers come together, the result is something remarkable. A display capable of showing vivid colors, deep contrasts, and incredible detail. For the first time, one of the most recognizable parts of the iPhone begins to take shape. But while the screen becomes the face of the device, another component is quietly becoming its heart: the battery. And building it safely is one of the greatest challenges in modern electronics manufacturing. Part 4. Building the battery that powers your entire day. Every feature inside an iPhone depends on a single component that most users rarely think about: the battery. Without it, the processor cannot calculate, the screen cannot illuminate, the cameras cannot capture memories, and the device cannot connect to the world. Yet creating a modern smartphone battery is one of the most complex and carefully controlled processes in electronics manufacturing. Inside specialized battery facilities, engineers work with highly refined materials that must store large amounts of energy while remaining safe, reliable, and compact. Every layer is measured with extraordinary precision because even tiny variations can affect performance. The manufacturing process begins with the creation of ultra-thin electrode materials. These layers are coated, dried, compressed, and cut with remarkable accuracy. Automated systems continuously monitor thickness and uniformity because consistency directly affects battery life and charging performance. Once prepared, the layers are assembled into tightly packed structures that maximize energy storage while minimizing size. Advanced machinery seals the battery inside protective casings before adding sophisticated monitoring circuits designed to regulate charging, temperature, and overall safety. Before a battery can move forward, it undergoes extensive testing. Engineers simulate charging cycles, temperature changes, and long-term usage conditions. Only batteries meeting strict performance requirements continue to the next stage. By the time the process is complete, a component no larger than a few stacked cards has gained the ability to power a device used for hours every day. Yet, even the most advanced battery is useless without the hardware that transforms electrical energy into meaningful experiences. And that hardware includes one of the most impressive systems ever miniaturized for consumer electronics. Part 5. The cameras that changed photography. There was a time when carrying a professional camera required a dedicated bag filled with equipment. Today, millions of people create stunning photographs and cinematic videos using a device that fits comfortably in a pocket. This transformation didn't happen by accident. It required extraordinary engineering and one of the most sophisticated camera manufacturing processes in the world. The journey begins with precision optical components. Tiny lenses are manufactured to exact specifications and polished to incredible levels of accuracy. Even microscopic imperfections can affect image quality. Multiple lenses are then arranged into complex optical systems capable of gathering light and focusing it onto advanced image sensors. These sensors contain millions of tiny pixels that convert light into digital information. Inside camera production facilities, robotic systems assemble components so small they appear almost invisible to the naked eye. Advanced alignment equipment ensures every lens sits in exactly the right position. Engineers verify focus performance, color accuracy, and image quality using specialized testing systems. Some manufacturing tolerances are measured in fractions of a human hair. The result is remarkable. A camera module small enough to fit inside a smartphone, yet powerful enough to capture high-resolution photos, cinematic video, night scenes, and detailed portraits. What once required professional equipment now fits inside a pocket. But while users often notice the cameras first, the real intelligence of the device lies elsewhere. Deep inside the phone, the logic board is waiting. Part 6. Building the brain of the iPhone. If the display is the face of the iPhone and the battery is its heart, then the logic board is undoubtedly its brain. This small circuit board contains many of the most important electronic systems inside the device. The processor, memory chips, wireless communication systems, storage modules, and countless supporting components all work together on this tiny platform. The manufacturing process is astonishing. Automated placement machines position microscopic components onto circuit boards at incredible speed. Some components are so small they can barely be seen without magnification. Yet every one must be placed with extreme accuracy. Advanced soldering systems permanently connect the parts while automated inspection equipment verifies alignment and quality. As production continues, more systems are added. Wireless communication hardware enables connections to cellular networks, Wi-Fi, Bluetooth devices, and satellites. Memory chips provide storage for applications, photos, and videos. Security systems protect personal information. Audio processors support speakers and microphones. Each component contributes to the overall experience users expect from a modern smartphone. The complexity is difficult to comprehend. Thousands of electronic connections operate together inside a device only millimeters thick. Yet when the process is complete, the logic board can process billions of calculations every second while managing countless tasks simultaneously. It is one of the greatest examples of modern miniaturization. Now the major components are ready. The screen exists. The battery exists. The cameras exist. The logic board exists. For the first time, everything needed to create an iPhone is available. The assembly phase can finally begin. Part 7. The moment thousands of parts become one device inside the final assembly facility, years of engineering and months of manufacturing converge into a single process. Components arriving from factories around the world are brought together to create the finished device. This stage represents one of the most carefully coordinated manufacturing operations on Earth. Assembly begins with the frame. The logic board is installed and connected. Cameras are positioned with extraordinary precision. Speakers, vibration systems, sensors, and wireless antennas are integrated throughout the device. Every cable must be routed correctly. Every connector must lock securely into place. The battery follows. Then comes the display. Specialized equipment carefully aligns the screen before permanently attaching it to the body. For the first time, the iPhone begins to resemble the product customers recognize. Yet appearance alone is not enough. Every assembly station performs verification procedures before allowing the device to continue. Sensors check connections. Software validates hardware communication. Automated systems ensure components function correctly. Thousands of parts have now become a single product. But before it can leave the factory, it must prove itself. Part 8. Testing every iPhone before the world sees it. Few people realize how much testing occurs before an iPhone reaches a customer. Every device undergoes a series of inspections designed to verify functionality, quality, and reliability. The goal is simple. Ensure that the experience users expect is delivered consistently. Specialized equipment activates the device for the first time. Cameras are tested. Displays are inspected. Speakers and microphones are evaluated. Wireless communication systems are verified. Sensors respond to automated commands while software checks performance. Additional testing examines physical quality. Engineers inspect the exterior finish under controlled lighting conditions.